This is like the the fourth time I'm doing this video, and it keeps failing. But I hope this is the last time I'll do it because this paper is very much interesting. And if you're in the field of information systems, this is one of the foundational papers you need to know in your fingers if you want to do design science, because you want to know how to position your research. You know, you want to understand how to also write your research paper. So this paper, positioning and presenting your research, design science research for maximum impact, by Gregory and Hevner, and this paper was published in 2013. So I want you to just take away your academic hat. I'm not here to just spit out a lot of academic jargons. I'm here to make sure that you understand what design science is all about and how to position your knowledge work. So I'm not here to just I'm really here to make you understand. So I want you to stay with me through the end of this video. And after that, you will come out having a strong knowledge of what design science is all about and what is expected of you in the field. So number two, before I go on and on, you need to understand that design science has a communication problem. And let's start with the problem. Design science is vital. We all know it. Like design science, the whole idea of design science is creating something and building something. Is how we create the actual tools, the strategies, and the systems that shape our real world, right? And communicating this should be a very important way so we can differentiate ourselves from routine designs or engineering design or any form of designs. But design science often have a communication problem. Many researchers, even up to now, struggle to explain exactly what their contribution is. Is it your code? Is it the theory? Is it the interface? Because of this, because of this confusion, great work often get misunderstood. Even if you have a wonderful work, it often get misunderstood. And this work, you know what happens? It gets rejected by reviewers who mistake it for more like consulting, routine design, or engineering project. So the authors of this paper state we haven't actually reached our full potentials because we are seeing gaps on how to communicate our research work, and we need to fix that. And that is what this paper is all about. So going to slide 3. So this is a very important thing to note. Any great research contribution must answer three problems. Yeah, whatever field you are in, engineering, and if you're creating something, and your contribution must answer three questions. And these questions are very mandatory in design science. One, is it true? Your methods, your evidence, or the way you come about the research, is it credible? Is it true? If it's not true and credible, if it can be replicated, then there's a problem. Number two, is it new? Are you just doing something that's already been done before? If whatever you're coming up with has already been done before, why would anybody care? You have to probably advance and innovate on something that has been done before. So it has to be new. You have to give us something new. Number three, is it interesting? Like, if it's not, by interesting, I don't mean the excitement. No, I mean, does it solve real world problem? Does it advance knowledge? If it doesn't solve a problem, nobody cares. And number three is the most important question you need to ask. Is my research, is whatever I'm building, does it solve problem? Does it solve a really important problem? This is this is the meat of, you need to answer those three questions, and the third one is the most important. And going to slide 4, now this paper introduces two powerful paths It gives a two powerful framework. This is the meat of the paper. You know, first of all, how do you position your contribution? How you position your contribution matters. What kind of contribution are you making? Where does your contribution stand? What kind of contribution do I even need to produce? So this is very important. And number two is presenting your research. Once I have this contribution, how do I present my research is very important. How do I present my research? So this paper actually offers guideline how to position your contribution and how to present your research. If you don't understand this yet, in the subsequent slides, I'm going to explain it. Now, all design science knowledge falls into two fundamental types. That's facts. To position your work, you must first distinguish between the two types of useful knowledge that form the design science knowledge base. Now, when it comes to design science, there is new two knowledge base that work in design science: descriptive and the prescriptive. Now, you have to ask me how. What is descriptive? Now, descriptive is, as the name implies, describing something. You know, it concerns the natural phenomenon. More like in social science, we creating theories. We're trying to describe the way things work in the real world. In natural laws, we come up with the laws of physics. We're describing things. You observe and you describe. That's descriptive knowledge, the kind of knowledge you use in the behavioral science. So you're trying to describe. Then number two knowledge you should know about is prescriptive knowledge. You're trying to prescribe the knowledge of the artificial. You're trying to prescribe to build something. This is where you use your knowledge, you use your creativity, and you decide to create something. You are prescribing, and this is the lambda knowledge. So here, the the kind of things, the artifacts you come up with, the constructs, your models, your method, your instantiations, your design theories. So this is the core knowledge that comes out of design science. But to inform this knowledge, to create anything, you need to find a theory. That's the called the kernel theory. So the kernel theory is more like the descriptive knowledge that informs your design. Before you design anything, you have to have a theory for the design, a theory of what you want to see, a theory of how you want to inform your design. So you pick up that theory from the descriptive knowledge. Then after you prescribe, you create another theory and add to the body of descriptive knowledge. So it's a loop. You use a descriptive knowledge to inform your design and create a prescriptive knowledge. And after you have the prescriptive knowledge, you have from there you come up with a descriptive knowledge, come up with a theory for your design. So it's a loop. So design science creates this prescriptive knowledge, but it relies on the contribution and contributes to also descriptive knowledge. So going to slide 6. Come on. So here is the DSR is a cycle of consuming and producing both types of knowledge. So to explain this, it starts with the left, the application environment, right? This is the real world where we find problems and opportunities. There's a lot of problems and opportunities in the real world, and we use our human capacity, our creativity, and our reasoning to draw from existing knowledge, what is already there. We look at what theories exist, we ask ourselves what theories exist and what tools already exist, right? Then we mix those ingredients to build something new. And the result is a contribution back to the knowledge base. And we add a new tool to the shelf and a new theory to the library, just as I said before. So this is the cycle of knowledge, right? So uh 7. So here is the meat of the paper. The matrix is this matrix is perhaps the most important takeaway of this paper. And I don't want you to stay with me. Um, this will help you identify where your contribution is, what your contribution you're making, and where you belong. So this is the meat of this paper. So This is actually based on two dimensions. On the bottom, you can see the application maturity. This is how well we understand the problem you're trying to solve. On the side, we can see the solution maturity. This is how developed are the existing solution. And depending on where you sit on this axis, your research falls into one of these four quadrants: invention, improvement, exaptation, and routine design. So these three quadrants represent where your contribution falls into. So going to slide 8 to explain better. So let's talk about the invention, right? This is when you're creating a novel solution, like whatever, when you're creating something that is not there before. So this is like a moonshot. If you don't know what a moonshot is, I suggest you Google it. So you're making a novel solution for a new problem that we barely understand, and this is like a radical breakthrough. And a classical example is the first data miming algorithm. So before this data miming algorithm, we didn't really have the concept of miming data for association, nor did we even have the tools to do it. So it wasn't there before. And if you're here, if you're in this quadrant, your contribution is often the conceptualization of the problem itself. You're like trying to conceptualize, maybe not actually building it, but try to conceptualize the problem. That's like a new invention. So, like I said, the challenge is that little may be known about the problem itself, and it itself it needs conceptualization. The value of the solution may be unclear initially. So, and a great paper that actually talked about this is the Agarwal et al. 1993, convincing conceiving of mining database for association rules and creating an efficient method to do so. So, like here, you're just coming up with something new, and you can see here is the application maturity is low, and that's the application maturity is low, and solution maturity is also very low. So that's the idea here. So on the next slide, that's slide 9. That's the improvement. So this is actually this is where most of our research lives, or most of the research you see in design science right now. This is where it lives. So here the application maturity is high. People are using people are people are using it, right? And we know the problem. We understand the problem we are trying to solve, but the solution is maturity is low, and current solutions aren't good enough. So we know the problem. We know how to. We know the application maturity is high, and but the problem is that the solutions to the problem is not good enough, and we want to improve it. So your goal here is to build more like a better mousetrap, a better tool, whatever. You're creating a solution that is more efficient, more effective, or higher quality than the one that already exists. The challenge here is to prove that whatever you're creating is better. So strong evaluation should show improved artifact or genuine advancement. So this is the aha moment for you. Like, if you want to contribute to design science, I think this is where you should be. You know, when you go out, look around for things, look around for places or equipment or devices that you think that you can improve in. You think that the current solution doesn't really work, and you feel that you can improve on this. That is where that is a huge contribution for you. So I urge you, when you go about your day, this is like your aha moment. Think about things that we use right now that you think that has flaws that you can improve upon, and that's a design science contribution. So on the next quadrant, number 10, expectation. Now, when we have expectation, this is a fascinating area. It happens when the solution maturity is high. We have the tools, but we apply it to a low maturity application domain, a new problem. So you are taking a known solution from one field and adapting, ex- exapting, adapting it to solve a problem in a completely different field. For example, you can take a sensor in the aviation and apply them to interview system for deception detection. The contribution here is showing how an old tool can unlock new doors. And think about it. What technology from other fields can you bring to a field that is familiar to you? Think about it. No, think about it. Right now, I'm currently, trust me, currently lost in thoughts. I'm currently thinking, you know, what technology can I bring to the organization? Just think about it. When you visit a factory or visit any place, look at what they use and think about how can I bring this into another domain. It can always click. It can always click. You just have to keep thinking. I don't know any yet. I'm just thinking as much as you are. Then the routine design. Finally, we have the danger zone. Like, if your contribution falls here, you're really not making any contribution. So here we have a danger zone, the routine design. This is where the problem is known and the solution is known. You know, problem is known and solution is known. If you're just applying the best practice to build a standard website or system, this is just a professional work. It's not a research. It doesn't generate new knowledge. To publish, you must actually move out of this box. You need to show that you are adding something new to the descriptive or prescriptive knowledge base, not just what's already there. Like if I'm designing a website, I'm not doing anything new. If I'm designing an app, I'm really not doing anything new. So you want to stay away from routine designs and probably stay somewhere around an improvement or exaptation. Invention can really be very hard because mostly everything new under the sun have been designed, unless you're Einstein. Me, I can't set myself up for that. So you have to stay in the probably improvement or exaptation. And okay, then slide 13. Here's the publication schema, a clear schema to help you structure your story. So once you position yourself, you need a way to structure your story, and once like I said, once you have positioned your work in one of these three research quadrants, you need to write it up. So this paper provides a schema, a template, a structure for your story. It flows it flows a logical flow. It has a logical flow. The introduction, the literature review, you have to review the literature to understand what is there. The method, the artifact description, the evaluation, the discussion, and the conclusion. You introduce, you review, you method, your artifact description, and evaluation, discussion, and conclusion. I'm currently thinking about the. I'm currently doing a design science research paper, and I'm thinking, did I really do all this work? where, where does my contribution fall into? Let me even think about it right now. Mm, I think my contribution falls into wait, an improvement. Yes, an improvement. So that's probably where everybody design contribution falls into. So evaluation, discussion, conclusion. While this looks standard, the content within this section is specific to design science. Yeah. So number 13. So let's zoom in on critical differences. And in your introduction, define goals of your artifact. In your literature review, don't just review literature, review existing artifacts. Review existing artifacts. And that's a Lamba knowledge, That's more like, yeah, the prescriptive knowledge, existing artifact, review existing artifact. The artifact description is the heart of your paper. The artifact description is the heart of your paper. This replaces traditional results sections, describes the architecture and design principles and evaluation. Mm. You must provide evidence. Does it work? Is it useful? This isn't just this is just irrelevant. You have to say, does it solve the problem? Providing the evidence. Interesting. Yeah. So yeah, I think the literature review that I did of recent, did I really survey the prescriptive knowledge? So here that is the difference between the literature review from design science and other science. So you have to ask yourself, what other prescriptive knowledge design? Oh, I see. Voila. Interesting. So number 14. Uh, whenever I do these videos, I learn a lot. And as much as I'm trying to teach you, I'm also trying to learn. So whenever I say it, I kind of like, my mind just run wide. I try to like connect things, make sense. So for me, too, is a form of learning and sense making. So in the introduction, the hook the readers explicitly state your contribution type. The research is an improvement project that addresses. Okay. Then the discussion, the clear victory, summarizes what was learned, and abstracts and abstract in summarize what was learned and abstract it and abstract it into the design principles. Don't just say we built this. Say here is a new knowledge we generated by building this. Mm. Don't just say we built this. Mm. Mm. Abstract. You know, what was I? What I just learned something new. Uh, in the introduction, hook the reader. Explicitly, explicitly state your contribution type. Most of us don't do this. What is your contribution type? You know, yeah. So number 15. I don't want to keep you here. Number 15. Ultimately, structure leads to impact. By contributing by using the contribution framework to position a paper, the and the publication schema to present it, you're using the contribution framework to position and the publication schema to present it. You provide a clear answer to those three big questions: is it true? Is it new? And is it interesting? As the author says, it's difficult to understand the theory without knowledge of the technique, and use this tool to make sure your technique and your theory are understood by everyone. So this is the idea behind this paper. I still make some mistakes, so I'll go back to the drawing book and see. All right. I just want to give a shout out to my mentors that have guided me so far. Uh, Jean, yeah, the 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 guy from Germany. I don't even know his full name. It's Jean Von, and Matthias, yes, great guy. And also, oh, can I forget Ture Tunanem? Yeah, I think I got that right. Then Amba Young, my professor. These are amazing people that have actually helped me in this journey. And thank you. Peace out.